Okay, let's get into functions. There are quite a number of things to discuss when it comes to functions. As from this point forward, pre-calculus forward into calculus and beyond, functions are, a large majority of what you talk about. So we'll do a number of video lectures on functions. In this video lecture, we're going to talk about relations and functions. So this is an introductory video lecture. In particular, our objective, determine whether a relation represents a function. Okay, first things first, what's a relation? Well, a relation is simply a correspondence between two sets, or if you prefer, a relationship between two sets. Okay, another way to describe it, when the value of one variable is related to the value of a second variable, we have a relation. Okay, when we have numerical relations, okay, we can express numerical relations as equations, as graphs, as tables, as a listing of ordered pairs, etc. And we'll obviously do most of our work with numerical relations, but we're going to take a look at non-numerical as well to help you make sense of it in this video lecture. Okay, relations, including non-numerical, can also be expressed by mapping, with arrows drawn to connect the inputs to the outputs. So the relation, you have the value of one variable is related to the value of a second variable, and we can show this using mapping and drawing arrows from the one variable, which is the input, to the second variable, which is the output. So here's an example. Let's take a look at animal life expectancy. Okay, so we have a relation between the animal and how long it expects to live on average. So we have 4 animals, a dog, a duck, a kangaroo, and a rabbit. And we have 3 life expectancies, 11, 10, and 7. And we can see there's a relation. The dog is related to the animal dog is related to the life expectancy of 11 years. The duck is related to the life expectancy of 10 years. The kangaroo happens to also be related to the life expectancy on average of 11 years. And the rabbit is related to the life expectancy of 7 years. So if we were to express this so this is our mapping. Okay, this is our mapping. We've mapped the input, the dog, you tell me the animal, and the arrow, I will tell you the average life expectancy. The input, you give me the animal. The output, I will give you the life expectancy. If we were to use ordered pairs, you might want to put that in quotation marks because these are not numbers, obviously. This relation would be expressed as follows, and I have set notation here. The first ordered pair would be dog as input, 11 as output. So dog, comma, 11. The second ordered pair, duck, comma, 10. Duck, 10. The third ordered pair, kangaroo, maps to 11. So kangaroo, 11. And the fourth ordered pair, rabbit, 7 years. So rabbit, 7. Okay, those are relations. Okay, so the set of all the inputs for a relation is called the domain. The set of all the outputs for a relation is called the range. Okay, so let's go back here to our animal life expectancy. The set of our inputs, dog, duck, kangaroo, rabbit in this case, well, those are members of our domain. And the set of the outputs, what's on the other end of the arrow, 11, 10, and 7, those are members of the range. So back to here, I wrote that down. Using the animal life expectancy relation, our domain is dog, duck, kangaroo, rabbit. Those are the things that those are the things we input, okay? And the range is what I tell you or what you're told as the output. When you give me the dog, I tell you its life expectancy. The range, again, we normally write the range in numerical order. You'll notice the domain is written in alphabetical order. So 7, 10, and 11 is the range. Okay, so that's a relation. Let's talk about a function. So a function is a special type of relation. Okay, it's a specific type of relation. It's a relation that associates, each element of the domain, each input, with exactly one element of the range, the output. Okay? So, I put this section in the box here. Basically, no input has more than one output. Okay? What makes functions nice to work with is they are predictable. Every time you give me an input, I'll give you the same output. Okay, so for example, for animal life expectancy, let's go back to our chart here. If you say, hey, what's the average life expectancy of a dog? And I say 11 years. And then you ask for duck, and then you ask for kangaroo, and then you come back to dog and ask again. Maybe you forgot. Hey, tell me the average life expectancy for a dog again. Well, I can't change this. It's still 11. Okay, so the average life expectancy for a dog is always 11. Okay, it's very predictable in this case. Okay, so for each input, there's only one output. So a dog only outputs to 11. Okay, the kangaroo only outputs to 11. So you can have different inputs go to the same output, but each input can only map to one output. That's what makes it predictable and useful. Okay, let's take a look at two examples to see how this works. So here I have gas station and the price per gallon. I have 4 gas stations, Chevron, Shell, Gulf, and Exxon. The price at Chevron is $2.09. The price at Shell is $2.16. The price at Gulf is $2.21. The price at Exxon is also $2.16. Okay, so what's the domain? Well, the domain is you give me the gas station, the inputs, Chevron, Shell, Gulf, Exxon. What's the range? The range is the possible outputs, $2.09, $2.16, and $2.21. Is this or is this not a function? It is a function because each element in the domain corresponds to exactly one element in the range. Every domain has only one arrow going to one place. Again, where it goes to, you may have 2 arrows going to the same place. You may have an output that's the same for 2 inputs, and that's okay. The key to the function is every input has only one arrow, therefore only one output. Okay, let's look at this example to the right here, which is the carats. The number of carats, let's say for a diamond, how much it weighs in carats, and its price. Well, a 7/10 carat diamond, $15.29. A 7/100th carat diamond, $1,575. A 7/500th carat diamond, $1,765. A 7/800th carat, $1,798. And as it turns out, another 7/100th carat diamond is $1,952. Okay, so let's take a look at the domain. The domain is what I can put in. Okay, what is the inputs? Okay, well, I'm inputting the weight of the diamond. I have 4 members of the domain, 0.70, 0.71, 0.75, 0.78. The range is the output. In this case, you output the price. You tell me the size of the diamond, I'll tell you the price. Okay, I have 5 members of the range. I have 5 different outputs, ranging from $1,529 all the way up to $1,952. I have 5 members of the range. Is this a function? No, it's not a function because this weight has 2 different prices. Okay, so this weight does not map to only one price. This weight maps to 2 prices. Nope, that's not a function. It can only map to one price. Okay, so it's not a function. At least one element in the domain, in this case it's this one, corresponds to more than one element in the range. This one corresponds to this price and this price. So this weight is not predictable. This one's predictable, a 7/10 carat diamond. The price for that is $1,529. This one's not predictable. Hey, what's the price of a 71/100th carat diamond? Well, it's either this or this. Therefore, it's not predictable. I have 2 different outputs, 2 different ranges, members of the range, 2 different prices for that input. Okay, let's do some examples to talk about whether or not, and we'll do these numerical examples. State the domain for each relation, state the domain and range, then determine whether the relation is a function. So example 1, I have 4 points. Okay, so what's the domain? Okay, the domain, well, the domain is the input, okay, which is the, in coordinate pairs, it's the x value. So my domain is 1, 2, 3, and 4. Those are members of my domain. Okay, what's the range? The range are the outputs, and they're the second number after the comma, or the second word in previous cases. So my range is 4, 5, 6, and 7. 4, 5, 6, and 7. Is this the function? Well, if it helps you, I'm going to go like this and just draw a bubble for my domain. And my domain is 1, 2, 3, and 4. Those are members of my domain. I'm going to map it. So I'll draw another bubble over here. This is the range, and my range options are 4, 5, 6, and 7. 1 maps to 4. 2 maps to 5. 3 maps to 6. And 4 maps to 7. Okay? Does every member of the domain only map to one thing in the range? And the answer is yes. The number 1 only maps to 4. The number 2 only maps to 5, etc. for 3 and 4. So yes, a function. Okay, that relation is a function. Okay, let's take a look at another example. Example 2. Okay, so here are my points. Take yourself my paper, I'll come up a little bit for you. Okay, my points in this case are the point 1, 4, the point 2, 4, the point 3, 5, and the point 6, 10. Okay, what's my domain? Okay, my domain again is the first numbers, the inputs, the x values, 1, 2, 3, and whoops, not 5, but 6. Those are, I have 4 members in my domain, 1, 2, 3, and 6. What are the members of my range? 4, I don't need to write it twice. Once I put 4 down, it's fine. 5 and 10. I have 3 members of the range. Okay, is it a function? Well, I'll kind of do my, this is what you often see in math textbooks, so I'll do it this way. My domain, 1, 2, members of my domain, I'm going to map it. and C. So my range is 4, 5, and 10. 1 maps to 4. 2 also maps to 4. 3 maps to 5. And 6 maps to 10. Okay. Does each member of the domain map to only one member of the range? Yes, 1 only maps to 4. 2 only maps to 4. 3 only maps to 5, 6 only maps to 10. That's fine. You can have a range, you can have a member of the range have more than one thing mapped to it. What matters is over here, each of these can only map to one over here. So you can only have one arrow coming off of each member of the domain. So yes, a function. Okay, let's look at one more example. And you can probably guess it might not be a function since we've just seen 2 examples of functions. Okay, example 3. Okay, my points are, I'm going to set up my set notation here. We've got -3, 9, -2, 4, 0, 0, so the origin is in there, 1, 1, and -3, 8. Okay, so what's my domain? All the inputs, let's see here. Normally you do them in numerical order. -3, okay, I've got a -3, I've got a -2, I've got a 0, I've got a 1, and I have a -3 repeated, so I don't write it twice. So I have 4 members of my domain. What are the members of my range? Okay, let's see here. I'll do 0, 1. Again, I'm going to put them in numerical order. 4, 8, 9. I have 5 unique members of my range. Okay, is this a function? Okay, let's go to here. These are the members of my domain. I'm going to map them. So -3, -2, 0, and 1. Over here, I have the members of my range. And I'll do 0, 1, 4, 8, and 9. Let's map them. -3 maps to 9. Okay, down to here. -2 maps to 4. Right to here. 0 maps to 0. 1 maps to 1. And -3 maps to 8. Okay, well there you go. Is it a function? Does every one of these, does every member of the domain only map to one member of the range? And the answer is no. -3 maps to 2 members of the range. -3 is not predictable. -3 can be either 8 or 9. We don't know. We know what 0 is. 0 gives us 0. -3 is not predictable, so no, not a function because of the -3 mapping, having the one input has, in this case, 2 different outputs, so it's not a function. Okay, so that's a bit on relations and functions, and we'll get into evaluating functions, etc., in upcoming video lectures.